Namaste. Today in this video we are going to discuss about hill climbing approach and genetic algorithm. Okay, in previous video we have discussed about best first search with asterisk search. Yes, so in this video we are going to discuss about hill climbing and genetic algorithm. So let us first discuss about hill climbing. Okay, so hill climbing. Okay, basically DFS with measure of quality that is assigned to each node in tree can be represented in hill climbing. Okay, and it can be compared with the blind man working in a hill. So let us consider a hill like this. Okay, let us consider this is a hill. So this is our global maximum value in a solution. Okay, and this is our local maximum, and this part is known as soldier. Okay, this part is known as soldier, and this is plateau, and this is valley. So when a blind man is here, okay, is here, then he move upward to reach the maximum value and reach up to this point. If he move downwards, then this will be less value. So for him this is the maximum value. But if a blind man is walking here and goes to this way, then this will be the maximum value, because if little bit forward it becomes downward. So this will be the maximum value for the blind man. But if the blind man is here and move maximum value, then here is the global maximum. Okay, similar for this valley and this local maximum. So it depends on how the program starts or where the starting position is. If the starting position is here, then we reach only global maximum. But if we are sorry, if we start from here, then this will be the maximum point. Okay, so disadvantage of hill climbing is foothill problem. Okay, that means might think the blind man has reached higher point, but just reach the local maximum. That is called foothill problem. That means if the solution starts from here, then the maximum point is here. That is foothill problem. Similarly, there may occur a plateau problem. That means the maximum value may reach here only. And next one is ridge problem. Ridge problem means if there is sharp edge like point, then the solution ends in that point. Okay, and that is called ridge problem. Okay, this is all about hill climbing approach. Okay, and we can compare it with a blind man walking in the hill. Okay, so let us discuss about genetic algorithm now. Okay, genetic algorithm. Okay, so genetic algorithm is basically a optimum search approach or optimal search approach which provide the optimal solution. It processes number of parallel search, okay, at a time, and normally it is similar to the biological genetic algorithm or genetics. Okay, we have read about the Darwin's theory. Yes, so it is similar to the Darwin's theory. Okay, so it is biological genetics. Okay, like as biological genetics, and use the biological genetics to solve the problem. The step can be, okay, like as the genetics which we read according to Darwin theory. Yes, that means selection of the fittest. Yes, overpopulation, reproduction, survival of the fittest. Okay, natural selection. These steps are included in genetic algorithm. So the outline. So the outline can be written as, okay. So first point is start. That means it's generate. Start means generate random population of n chromosome, that is suitable solution for problem. Okay, next step is fitness. That is evaluate the fitness effects, okay, of each chromosome X in the population. Next, third one is, okay, new population. Okay, create a new population by repeating the following step until the new population is completed or completes. Okay, so first point in loop is selection. So selection means select two parent chromosome from a population according to their fitness. Better the fitness, bigger the chance of the selection. Okay, next one is crossover. Okay, that means with a crossover probability, crossover the parent to form new offspring or children. If no crossover is used, then offspring is exact copy of the parent. While selected two parents, we crossover it. If no crossover occur, then the offspring is exact copy of parent. So C. Third one is mutation. Okay. While mutating, we use a mutation probability and mutate new offspring at each locus. Okay, locus means the position of a chromosome. Each locus and form a new population. Okay, so fourth part is replace. After the new offspring is formed, then we replace the two parents which we have selected in previous, okay, and use new generated population for a further run of the algorithm. Okay, fifth one is test. If the in condition is satisfied, that means new population generates new optimal solution, and then we return to the best solution in correct population. If not, we have to again reselect the population, okay, crossover and mutate. And step 6 is loop. Okay, if test is not finished, we have to go upward, go to step 2. Yes, so this can be represented in a flow chart. Okay, flow chart. Let us consider flow chart. Okay, start. Okay, Now select population, that means generate n individual. It means generate n individuals. Okay, so this step is known as genesis. Next one is scoring. Scoring means assign fitness to each individual. Okay, it is assign fitness to each individual. Okay, next one is selection. Okay, again select two individual. Now from the population we select two individual. So after selection, what we have used? After selection, crossover and mutation. Yes, so we use now crossover. Okay, we use crossover operator to produce new offspring. So this is called crossover. And next one is, again we calculate the fitness. Okay, that is called scoring. So assign fitness to the offspring, scoring. If scoring is correct, that means crossover finished or not. Okay, if crossover is finished, then we move to next step. Okay, that is select one offspring, okay. If not, we have to again go and select two parents. If yes, okay, again the selected offspring is, again we have to apply mutation. Yes, mutation. So we apply mutation. Okay, apply mutation. And produce a new offspring. So after producing a new offspring, we again calculate the fitness. So that is scoring. Okay, and again we check is mutation finished or not. That means does the fitness is better than previous or not. Okay, so we check. If yes, we apply replacement operator. Yes, that is survival of the fittest. So if yes, we apply survival of the fittest. That means apply replacement operator to replace the old population by new individual in the given population. So if mutation is finished, we replace the old population by new offspring. If not, okay, if mutation is not finished, then we have to again select another offspring. Okay, and if survival fittest, then we check new selected population or new population, group of population is optimal than previous or not. That means terminate. Okay, if it is terminated, then if the solution is optimal, then we have to finish the finish the our process. If not, again we have to select 2 individual from the previous population. Okay, in this way the genetic algorithm works. So let us consider an example and solve by using genetic algorithm. Okay, and before doing an example, okay, let us discuss about something about crossover. Crossover can be classified into 1 point, 2 point, uniform crossover, and automatic crossover. Okay, 1 point mean only 1 point change. Okay, that means the number is represented into binary form and a single point or single section is changed. That is called 1 point crossover. 2 point crossover means 2 sections are changed, interchange. Okay, and uniform crossover are done according to the ratio of one population with ratio of second population, and automatic crossover are done according to the arithmetic equation. Okay, so mutation can be flip bleed mutation, boundary mutation, non-uniform mutation, Gaussian mutation. Okay, these are the types of mutation. If you want to know more about the mutation, you can view it in web page or Google. Okay, Google it. So let us consider an example to solve the problem by using genetic algorithm. So maximize function fx equals to x square over the range of integer from 0 to 31. Okay, if we are using the simple mathematics or the mathematics we have used in intermediate level, then we use the derivative, yes, and differential equations by taking derivative, first derivative, second derivative, and comparing the inputting the values. We take positive or negative, and according to that we calculate the maximized value, yes, according to intermediate mathematics. But by using the genetic algorithm we can solve this process. Okay, so let us solve this question by using genetic algorithm. So first of all, maximize function, okay, fx is equals to x square, and we have 0 to 31, the range is 0 to 31. So converting into binary bits, the maximum number of bit we required is 5 bits, yes, because 140 is 140 is sorry 1 5 to okay, sorry, if 51 then it gives 31, yes. So the maximum number of bit we require is 5 bit. So assume, okay, let us assume some solution. Okay, so the range is 0 to 31. Let us assume some binary bits 0 1 1 0 1 1 1 0 0 0, yes, 0 1 0 0 0 1 0 0 1 1. Okay, so this is the assumption only. Okay, you can assume another number also. So converting it into numbers, it is 13, it is 24, it is 8, and it is 19. So calculating x square, that is fxs. So x square 169, 576, 64, 361, and we have to calculate the probability also. So we use this. Okay, expected count is equals to n into probability of I. Okay, where n is number of total data, that means there are total 4 data, so we use n equals to 4. Okay, so now Sn 1 2 3 4 data. So initial population Okay, that is also known as chromosome. Okay, so 0 1 1 0 1, first one is, second one is 1 1 0 0 0, third one is 0 1 0 0 0, fourth one is 1 0 0 1 1. Now x value, so x value is, it is 13, 24, 8 and 19. That means its binary value. Okay, its decimal value is 13. Next one is fitness. Okay, that is fx. This is also known as fitness. Okay, fitness. So 13 square was 169, 24 square was 576, 8 square was 64 and 19 square was 361. Okay, so probability. Okay, before calculating the probability, we calculate summation x square, that is total sum. So that is 1170. Okay, so calculating probability, 169 by 1170 is 0.14. Similarly, 0.49, 0.06, 0.31. Okay, now expected count. Okay, expected count is n into probability. Yes, so n is 4 into 0.14 is 0.58, similar 4 into 0.49 is 1.97, similarly 0.22 and 1.23. Okay, and average is our, so it is 1 4. Yes, it is 293, 0.25 and 1. Maximum value among this is 576, among this is 0.49 and among this is 1.97. Okay, this is the table which I have drawn. Now, so string 2 or the 2, this part has maximum value, as we have to find the maximum value x, so that the x square is maximum. Yes, so the maximum value is given by second line, or that is 24. Okay, now we produce a new gene or population. Okay, so now produce new gene or population or offspring. Okay, so our string was, okay, number was 01101, 11000, 01000, 10011. Okay, and probability was, okay, 0.14, 0.49, 0.06, 0.31. Now by using this probability, we form a range and generate some number of random number and check whether it lies in this range or not. Okay, so that is known as associated associated binary. So this is 0 to 0.14. okay, this is 0.14 to 0.14 plus 49 is 0.63. Similarly, 0.63 to, if we add 0.06, it gives 0.69. Similarly, 0.69 to 1. Okay, now we generate some random number and check whether it lies in this range or not. Okay, so since we have considered only 4 data, so we generate 4 random number. So now generate n, okay, that is 4 random number between 0 and 1. Okay, so I have generated, okay, I have generated 0.08, 0.24, 0.52, 0.87. Okay, you generate the 4 random number in the calculator rand, okay, using rand function. So it falls in which range? Okay, so 0.08 lies in this range. Yes, that means 0 to 0.14. 0.24 lies in this range, 0.14 to 0.63. 0.52 also lies in this range, 0.14 to 0.63, and 0.87 lies in this range, so that is 0.69 to 1. Okay, so choose unset. So 0.014 means 0.1101. Yes, and next one is this one. Yes, that is 11000. Next one is also 11000, and this one is where it lies, 1 it lies in 10011 in this range. Yes, now we use crossover now, or mutate. Okay, mutation is used between these two and these two. Okay, or we can use the mutation between the previous population also. Okay, these two and these two to generate new population. So let us use crossover in 01101 11000. Okay, this is the first two population. Second one is 01000 10011. Okay, now I am using only 1 bit crossover. Okay, that means 1 point crossover. I am taking crossover only this. Okay, this part only. So it gives, interchanging these two part, we get 01100 and 11001. So in this case, if we flip this 2 bit, 01001 11010. Okay, now our new population, our new solution is 01100 11001 01001 10010. Yes, so 1100 is 12, it is 25, and it is 9, and it is, okay, 16 plus 2 is 18. Okay, so this is the new solution, and again we solve the problem from start. Okay, by taking this population we solve the problem from this starting point. Here it was 24, now we got value 25. So until we get 31 we repeat the process. In this way we generate the maximum value of x, so that the given function is maximized. If we get use 25, then it gives 625. It was 576. Yes, so it is maximum value than the previous. So it runs the process iteratively until the maximum value is not given or not occurred, and provides the optimal solution. So in this way the genetic algorithm works. Okay, and in next video we will be discussing about the next chapter, that is adversarial search, chapter number 4. Okay, and the important questions that can be asked during the exam for this chapter is asterisk search, depth first search. Genetic algorithm is normally asked in short notes. Okay, and depth first search and breadth first search, differences between asterisk and base first search. Okay, so we'll be discussing in next chapter. Okay, thank you and bye bye.